Number 20. In the year 1900, the total number of metric tons of copper produced in the world was 495,000. Each year since 1900, the total number of metric tons of copper produced has increased on average by about 3.25% over the amount produced the previous year. Which function models the total number of metric tons of copper produced in the year that is X years since 1900? So looking at our answer choices, we notice that this is set up as an exponential function. So what we need to figure out is whether this is a growth, decay, or a constant. And we can find that out by finding some keywords in our question. So if we read here, it says that the total number of metric tons of copper produced has increased on average by 3.25%. So that increased tells us right away that this is a growth function. So I'm going to write that right here, that this is growth. If you guys remember, our growth formula is A equals A sub 0, 1 plus R to the t power, where A sub 0 is our starting value, R is our rate, and t is our time. So I'm going to go back into our problem and start labeling A sub 0, R, and t. So our starting value here is 495,000. So that's my A sub 0. My rate is always expressed in a percent unless it's a constant function. So right here it says 3.25%. But remember, we can't keep it as a percent. We need to turn it into a decimal. So you can do that by moving the decimal 2 units to the left or taking this number and dividing it by 100 on your calculator. So when we move it 2 decimal places to the left, we get 0.0325. So this is our rate. And then lastly, it says time. So down at the bottom right here, it says X years. So that means our time is just going to be the variable X. So now that we have all our information, we can plug everything in. So this says we didn't find anything for A, but if we look at our answer choices, notice that A is expressed by C of X. So that's what I'm going to write. I'm going to write C of X equals. Then I have my A sub 0. Well, we said A sub 0 is our 495,000. And then in parentheses, I have 1 plus my rate, which is 0.0325 to the x power. So all I need to do here is combine what I just found inside the parentheses. So if we add that together on our calculator, we get C of x is equal to 495,000 and then 1.0325 to the x power. So looking at our answer choices, the only one that it looks like it's close to is letter choice A. Letter choice A. So if we look at the rest of them, it looks like B, what they did instead of doing 1 plus, they did 1 minus, so they thought it was a decay function, so that's why B was incorrect. And then notice C and D has X as our rate, and it has the actual rate as our time. So they switched up these numbers here when those should be in the opposite places. So that's why both C and D are wrong, and we're left with the answer choice of A.